understanding the intricacies of what POSIX compliance actually is a really, really complex topic, but we can at least talk about it in the abstract of what it means for something to actually be POSIX compliant. Now, typically when people refer to POSIX compliance, they're referring to it in a very narrow concept. They're referring to it as the shell and various terminal applications. So for example, the GNU implementations of things like awk, sed, and cat have extensions to them which are not POSIX compliant, and the same is true for bash as well. While bash actually does implement a lot of the POSIX spec, in some ways it doesn't conform to it perfectly, and it also has extensions which aren't actually in that specification. So POSIX stands for Portable Operating System Interface, and like with a lot of Unixy applications like Linux, the X comes from Unix. And this name was actually suggested by Richard Stallman because the original name, because this was created by the IEEE, they wanted to call it IEEEIX. I have no idea how you're supposed to pronounce that, but RMS didn't like this either, so he suggested POSIX. Now, initially the pronunciation was actually supposed to be, and this really hurts me to say it like this, it's supposed to be POSIX, but the world isn't America, and I will never say it like that again. So in the days where Unix was king, enterprises started to understand that there was a need for standardization because let's say you have company A, and company A is running Unix A, and then you have company B running Unix B. Now, even though they are both running Unix, there was no guarantee that applications written for one system would even run on the other one, or that you could even communicate between these two systems altogether. And that's because Unix isn't just one single implementation. There were all of these, I guess, different implementations of Unix, some of them compatible with each other, and some just completely incompatible. So as a means to easily port applications between these systems, there was a need for a consistent standard, and Unix was chosen as this standard because it was manufacturer neutral. So it's not like you have to go to, say, Microsoft and then be like, okay, Microsoft, we're going to completely redesign your operating system just from the ground up. With Unix, you can just say, okay, well, we're going to just make another Unix operating system, and that's basically what POSIX is. So POSIX can be thought of as a specification for what a Unix-like operating system should be to be compatible with other Unix-like operating systems. So following the POSIX specification doesn't limit a system to what it can do. The POSIX spec only says what a system must be able to do. So for example, let's say you re-implement the Bourne shell, not Bourne again, that is bash. If you re-implement the Bourne shell, just make a perfect clone of it. Obviously, this will be a POSIX compliant shell, but let's say you want to go and add some extensions to it to do, I don't know, syntax highlighting or things like that. As long as you have that minimal subset there that is POSIX compliant, this will still be a POSIX compliant shell. Assuming obviously that adding in those extra features doesn't actually go and break the POSIX compliance. Now, when two systems are known to be POSIX compliant, it allows for a developer to make assumptions about what is actually possible on that system. So if something is POSIX compliant, you know exactly what C library is going to be available, and you can actually design your application around that C library actually being there. Whereas if you implement the application with some other implementation of the C library, there's no guarantee that what you're working with is going to be available on the system you take the application to. So it allows for significantly easier development in this regard, but it also allows for users and developers alike to work with things like sed and awk and cat and echo and things like that in a much easier way, because let's say you want to use sed and awk in a shell script. Well, if you work with the POSIX implementation of sed and awk, you know that any system that implements those POSIX compliant features will actually have those features there. Whereas if you say work with the GNU implementation of sed, the GNU implementation adds extra features in which might not actually be available in, say, the Plan 9 version or some other version of sed. Now, while I've been talking about Unix this entire time, a POSIX compliant operating system and POSIX compliant applications don't actually need to be on a Unix-like system or even have a single line of Unix code in their actual implementation. So for example, let's say that Microsoft decided that in the next version of Windows, they are going to perfectly meet the POSIX specification. Even though Windows is not Unix-like whatsoever and it has not a single line of Unix code in it, if it meets the specification, it will still be a POSIX compliant operating system. Unix was chosen at the time because it just made sense for the time period, and all of these applications already existed within a Unix context. But if the spec is met, then the spec is met. I mentioned earlier that POSIX is more than just the shell and terminal applications, and it can actually be broken down into multiple standards, 4 in fact. So prior to 1997, we had POSIX 1, POSIX 1b, POSIX 1c, and POSIX 2. So POSIX 1 was the core services. So this was process creation and control, signals including floating point exceptions, segmentation / memory violations, illegal instructions, bus errors, and timers. And then we also have file and directory operations, pipes, the C library, which is the standard C library, I/O, port interface and control, and then process triggers. Now after that we have POSIX 1b, which is real-time extension. So this is priority scheduling, real-time signals, clocks and timers, semaphores, message passing, shared memories, asynchronous and synchronous I/O, and memory locking interface. Then we have POSIX 1c, which is threads extensions, thread creation control and cleanup, thread scheduling, thread synchronization, and signal handling. And then finally, we have POSIX 2, which is shell and utilities. And this is, as I mentioned earlier, what people typically talk about when they're talking about POSIX. So this is the command interpreter, otherwise known as your shell, and utility programs. So awk, grep, ls, sed, echo, cat, things of that nature. So if you're a very boring person and you want to go and read the POSIX specification, you can very easily find it online, and I'll leave a link to it down below. It's published by the IEEE and the Open Group. And let's actually go see some of the things that are included inside of it. So let's go over to shell and utilities, just because this one is fairly applicable to most people watching this video. Let's just go to the shell introduction. And what this actually defines is everything that a POSIX compliant shell needs to do. So for example, it talks about how quoting should be handled. It talks about what the escape character should be and what the escape character should do. It talks about how single quotes and double quotes should be handled. Token recognition. I think there's something in here about reserved words. So these are the words that are reserved for special meaning within the language. We have how parameters and variables should be handled. We have some of the special parameters. Let's see, shell variables. So we have what the home variable means, what IFS means, what lang means. Basically, this goes through everything the shell needs to do to be a POSIX compliant shell. So if you want to go and implement a POSIX compliant shell, go and become, I guess, very familiar with what's being said in this document. Because only half implementing this POSIX specification for one part is about as useful as not implementing it altogether. Now, there is still some value in only implementing it for certain parts of your system, but make sure you implement it for the entire part of that system. So let's say that you only implement, I don't know, half of the POSIX stuff for sed. Well, without going and reading all of your sed documentation, I don't know what parts of it are actually POSIX and what parts aren't. So that completely removes all of the, I guess, ease of development of knowing that it is POSIX compliant. So doing that doesn't really add any value. But if you just want to have, say, only a POSIX compliant shell and only have POSIX utility applications, and let's say you only want to have, I don't know, a POSIX C library. If I know that those parts of the system are going to be POSIX compliant, I can still develop my application, I guess, knowing that those parts are. Even though other parts of the system aren't going to be, if I'm not making use of them, it's not really a problem for me right now. But going on to other parts of the POSIX spec, if we go back to the base definitions, this will even include like what C headers should be here, and if we go into this, what all of the variables should be, what all of the functions should be. Basically everything you need to know to make a Unix-like operating system. This is why I say that POSIX is basically a minimal specification of what a Unix-like operating system should be, because if you go and read through this, you'll see you have everything you actually need to know to make a Unix system. Now, for most systems, just being POSIX compliant and meeting the specification is perfectly fine. But if you want to go that extra step and actually get your operating system to be a POSIX certified operating system, the Open Group and IEEE actually do manage a POSIX certification program, where basically they'll run a bunch of automated tests, and if you fail any of the tests, then your system is not going to be POSIX compliant. So things like, say, Linux, FreeBSD, and OpenBSD are mostly POSIX compliant, but they haven't actually been certified as POSIX compliant by the IEEE and the Open Group. Whereas, curiously, things like macOS, at least to an older version of the specification, is actually POSIX compliant. And some others include Euler OS, Solaris, True64, and you can go find a full list on the Wikipedia page, or there is also a list on the Open Group website right here. And POSIX compliance also forms part of the single Unix specification, which is a larger subset of what a standard Unix implementation should be. And if your system meets that specification, then you can market it as a Unix operating system using the Unix trademark. Now, I've been saying Unix sort of interchangeably with the trademark. There's the lowercase Unix and the uppercase Unix. Now, the uppercase Unix is the trademark. Typically, when people refer to Unix or Unix-like operating systems, they're using the lowercase version. Now, the important question is POSIX compliance still as important today as it was in the past? Now, there's two ways to address this, and the first one is from the user's perspective. So, as a user, it doesn't really matter if you want to switch over to something like Fish, or switch over to ZSH, or use other implementations of SED like the GNU implementation, actually make use of the extra features, because typically a user isn't going to be, trying to port their system to all these other sort of systems out there. They're usually going to pick one thing and then use it for a year, maybe 2 or 3, or just many, many years after that. So from the user's perspective, it's not really that big of a deal if you start adding in things that aren't POSIX compliant. However, from the developer's perspective, I would say that standards are still just as important today as they have been for the past 40 years. Having that standard there, knowing that you have POSIX compliance there to always fall back on is very, very important. It makes it so much easier to know if your application is actually going to run on all of these different Unix-like operating systems. So hopefully that somewhat answers the question about what POSIX actually means. So I think that's pretty much everything for me. Before I go, I would like to thank my supporters. So a special thank you to Joachim Corbinian, Andrew Craig, Nathan Montaza, Joseph, Peter D. Rode, Tony, Brennan, Donald, John, Mark, Mikkel, Nate Dog, Nephite, Tees, and Zilva. If you want to go and support my work, there'll be some links down below to my Subscribestar, LibrePay, Patreon, all of that sort of stuff, and a coin tree as well. I've got my podcast, which is Tech Over Tea, available basically anywhere, and this channel is available on Library, Odyssey, BitTube, and some other platforms as well if you want to watch on a platform that isn't YouTube. So I think that's pretty much everything for me, and I'm out.